Hey, what's up guys? This video is for section 8-9, which is perfect squares. And we are going to talk about one specific perfect square, which is a perfect square trinomial. Remember that we are factoring different polynomials, and a perfect square trinomial is a trinomial where the first and the last terms are perfect square numbers, which means that they have a perfect square root. And this is another special case that you guys can learn to factor a polynomial. It's a little bit faster than doing the traditional way to factor. So what is a perfect square trinomial? Let's look at some examples here. This one is 16x squared plus 24x plus 9. Notice the first term, 16x squared. 16 is a perfect square number. It has a perfect square root. And if you guys don't remember those numbers, that's why I have the list down here. You guys can check those out. But 16 is a perfect square number. And the last term, 9, is a perfect square number. They do have a square root. Now, one of the things with a perfect square trinomial is this term and this term, the first one and the last one, are perfect square numbers, but the last term has a plus. It is a positive number for this. It has to be a positive number for this to work. So once you know they are perfect square numbers, the way you guys will factor is by using two binomials. You're going to set up your answer. You're going to take the square root of 16x squared. So the square root of 16 is 4. The square root of x squared is x. So you guys have 4x and a 4x in your parentheses. And the last term, 9, the square root of 9 is 3. So you put a 3 here and a 3 over here. Now, in a perfect square trinomial, we are going to have the same sign for both binomials of the two parentheses. So the sign in the middle, the term in the middle, determines what sign you are going to use. So since this is positive 24x, we're going to put a plus here and a plus over here. You notice the two equations, the two parentheses, not equations, the two parentheses are equal, 4x plus 3. So you guys can rewrite that as a binomial, one binomial with a square. The square tells you that you guys have two of the same parentheses or the same binomial. So 4x plus 3 squared is your answer. Now, if you're wondering what happens to the middle term, well, let me show you guys that when you distribute, when you actually multiply, we know that 4x times 4x, that's going to give us 16x squared. We know that 3 times 3, that's going to give us 9. But when you multiply these two terms, 3 times 4x, that's going to be 12x. And when you multiply these two terms over here, 4x times 3, that's going to be 12x again. When you guys combine those two, 12x plus 12x, well, that's going to give us our 24x, which is the term in the middle, positive 24. So eventually, you guys, when you distribute, you will get the trinomial back. And that's the idea for factoring. We want to undo the distributed property, but when you actually do the distributed property, you have to get the trinomial back. So the second example, same thing here. You guys do have a perfect square trinomial. And notice the first term, 81x squared, has a square root. 81 is a perfect square number. And 25 has a perfect square number. And the sign of the last term is positive. It has to be positive in order for this to work. If it's negative, this is not going to work because you're not going to get the trinomial back if you distribute. So the square root of 81, that'll be 9x. And 9x over here, we have an x squared, so we need an x and an x. And the square root of 25 is 5 and 5. And the middle term is negative, so that's why we need a negative and a negative. And when you guys rewrite this as a binomial squared, you will get a 9x minus 5 with the square. Remember that the term in the middle, it determines the sign you guys need to use for the two binomials, because when you multiply, when you distribute, these two terms here and these two terms here, you have to get a negative 90x when you combine. All right, so let's go ahead and try and factor some perfect square trinomials. So the first one I'm looking at is x squared minus 24x plus 144. So first of all, I need to look at the first term, and the first term we have an invisible 1 next to the x squared. So this number 1, it is a perfect square number. It has a square root. And this one here, 144, it also is a perfect square number. It has a square root. And it is a plus 144. So you guys can factor this one by using two parentheses here. I'm going to take the square root of 1x squared, and the square root of 1 is 1, and the square root of x squared is just x. So you have 1x and a 1x. Now we all know that you don't need the 1 next to the x, so I'm just going to erase the 1 here because that's just an invisible 1, so you have an x and an x. And when you guys take the square root of 144, that's going to be 12. So you put a 12 here, 12 over here, and the middle term that tells you what sign to use. So we do have a minus here. I'm going to put a minus right here and a minus over here. Now, if you guys are wondering what happens to the middle term, remember, if you multiply, I'm going to multiply these two terms, negative 12 times x, that's negative 12x. And when you multiply x times negative 12, that's going to give you negative 12x. And when you combine those two, you guys will get a negative 24x. So we do get the term in the middle. We're okay. So this is your answer. Remember, you can rewrite it as a binomial squared. So I'm going to put an x minus 12 with the square. So this is my factors. We have two of them, and it is a binomial with the square. So the next one, same thing. You guys have an x squared plus 14x plus 49. We want to factor. So I know x squared has an invisible 1 right here. 49, it is a positive, and 49 is a perfect square number. So I'm just going to set up my two binomials here, and I'm going to use the square roots. Now remember that we are using a special case where you guys can factor by using the square roots. This is a perfect square trinomial. In my previous videos, I show you guys that you can actually multiply a times c, and you guys use the x method to factor. You guys can do that too in this one. It will work, but it's going to be a little bit more work because you're going to have to multiply the a times the c. You're going to find two factors that multiply to the product of a and c, and at the same time they add to 14. Now this one works when you use square roots because it is a perfect square trinomial. So it's a little bit faster to factor. When you take the square root of 1x squared, that's going to be 1x, 1x. So you put those x's at the beginning of the parentheses. And when you take the square root of 49, it's going to be 7, 7. And the middle term is positive. So I'm going to put a plus right here and a plus over here. So now you just rewrite your binomial, x plus 7 squared. Now you guys, it's a very good idea to check if you guys get that sign, the term in the middle. So if you multiply these two, you can do this mentally. 7 positive 7 times x, that's 7x. Keep that in your mind. And then you multiply x times 7, that's another 7x. And when you combine 7x plus 7x, you get that 14x. Now this one is when the first term is not 1. The previous two examples I showed you guys, the first term was 1. Now we have a 4 right here. Notice that the first term, it is a perfect square number. And the last term, 9, is also a perfect square number. And it is a positive. Remember that if that sign is negative, you have a minus 9. It's not going to work because the special case, when you multiply, you're not going to get the trinomial back. So make sure you guys do have a plus at the end in order to say it's a perfect square trinomial. So you guys are going to set up your answers, just two parentheses like this. You're going to take the square root of the 4y squared, and that's going to be 2y. The square root of 4 is 2, and 2y over here. Then you guys take the square root of the 9, and that's going to be a 3 and a 3 over here. Now you guys will use the term in the middle. There's a plus, so you put a plus right here and a plus over here. Now you guys write this as a binomial squared. We have a 2y plus a 3 with a squared. So there's my answer. We factored the perfect square trinomial. Now let's go ahead and look at when you have a perfect square trinomial with two different variables. Notice the first term, it has one variable with the square, so we have 25x squared. 25 is also a perfect square number. The last term, 49, is a perfect square number, but it has a y squared. So you guys do the same concept by using the square roots, but we are going to have an extra variable with the y squared. Notice that the last term is positive. That's a good sign. It actually has to be positive in order for this to work. So I'm going to set up my two binomials, my two parentheses here. I'm going to take the square root of the 25x squared, and that's going to be 5x with the 5x over here. I'm going to take the square root of the 49y squared. The square root of 49 is 7, but the y squared becomes a y when you take the square root. Remember that the square root and the square cancels, So if you take the square root of the y squared, you're just going to have a y because the square and the square root cancels. Then you guys put the 7y over here. You do the same thing for the sign with the term in the middle. It's negative, the one in the middle, so you put a minus and a minus. Now, if you guys are thinking, what happens to the middle term? Once again, you guys can multiply these two terms, negative 7y times 5x. That's going to be negative 35xy. You guys need to put the variables in alphabetical order when you multiply. And 5x times negative 7y, that's a negative 35xy. And when you combine those two terms, you get negative 70xy, which is the term in the middle. So now you guys write your binomial with the square. So we have a 5x minus f7y with a square. So let's try this one here. 9x squared minus 6x plus 4. So we know that the first term, 9, is a perfect square number. The last term, 4, is a perfect square number. So when you guys factor, you are going to use the square roots of the numbers. I'm going to take the square root of 9x squared. That's going to be a 3x and a 3x over here. And the square root of 4, well, that'll be 2 and 2. The 2 doesn't need a y, doesn't need a variable, because the 4 doesn't have a variable. It's just a number. And the sign in the middle is a minus. I'm going to put a minus here and a minus over here. But I want you guys to notice, if you check, if you get the sign in the middle and the term, the actual term in the middle, when you multiply those two terms, you get negative 6x. And when you multiply these two terms, you get negative 6x. And when you combine, we get a negative 12x. Well, guess what, guys? This one here is not the term in the middle. So since it doesn't work, you guys are going to write prime. Now you guys can also check and try the next, the other method I show you guys, and I'm just gonna do it here on the side so you guys can see. If you try to do the x method, remember that we do a big X here. You multiply a, which is the first term, and c, which is the last term. 9 times 4, that's going to be 36, and the middle term is negative 6. Now you guys need to find two factors that actually multiply to positive 36 and add up to negative 6. Well, guys, negative 1 times negative 36 is positive 36. They don't add up to 6. Positive 2 and 18 is 36. They don't add up to negative 6. And you guys can try the negative with the negative. It's not going to work. Negative 3 times negative 12, that's not going to give you negative 6. They multiply to positive 36, but not add to negative 6. Negative 4 and negative 9, well, that kind of looks like a negative 6. It will give you a negative 6, but it doesn't. If you add negative 4 minus 9, that's negative 13. If you subtract, you get 5. So it doesn't work. So it doesn't work when you guys try this method. So that's why the trinomial is prime. You cannot factor, it's not factorable for this perfect square trinomial. Now, sometimes in a trinomial or binomial or any polynomial, you can actually factor out a GCF first. Every time you guys start factoring, that's what you want to check first. If you can factor a number or a variable, you have to. And then you guys start factoring the perfect square trinomial, or maybe you guys have a regular quadratic trinomial, or maybe you guys have a binomial, whatever polynomial they give you guys. But let's try this one here. We want to factor out the GCF first. So I'm looking at the numbers 2, 36, and 162. There's a trinomial. I know I can factor out a 2. So I'm going to put a big parenthesis, only one, factor out the 2. So when you guys take out the 2, you will get a g squared minus 18g plus 81. I'm looking at the first term inside of the parentheses. We have an invisible 1, and the last term is an 81. So that is a perfect square trinomial. They are both perfect square numbers. So I'm going to factor out, sorry, not factor out, I'm going to factor the trinomial. I already factored out the 2. Let me bring down the 2 here so we don't forget that number. But I am going to use the square root of the first term, 1g squared, that's 1g and a 1g. I'm going to take the square root of 81, that's a 9 and a 9, and I'm going to put a minus for both binomials because we have a minus in the middle of the trinomial. There's the minus 18g. If you guys multiply negative 9 times g, that's negative 9g. Keep that in your mind. G times negative 9, that's another negative 9g. Negative 9g minus 9g is negative 18g. So this one works. So now you just write down your answer. You bring down the 2. There's your binomial, g minus 9 with a squared. Now this one here, you can actually factor out a variable. Every term has an m. And even though, guys, I know the 16 and the 36, they are perfect square numbers. That happens sometimes where you guys have perfect square numbers, but you can actually factor out a greatest common factor. You can factor out a 4. And if you guys can do that, you must factor out GCF. Every time you guys have one, take that number or variable out. So even though we have a 16 and a 36, they are perfect square numbers, I am going to factor out the 4 and the m. So when you guys factor that out, we are going to have a 4m squared. Remember, you took one m out, so we have an m squared minus 12m plus 9. 36 divided by 4 is 9, and you took out the m. Notice the trinomial. The trinomial, you still have a 4 and a 9, which are perfect square numbers, so you can still factor the trinomial. So now, I'm just going to factor this out right here. I'm going to take the square root of 4m squared. That's going to be 2m and a 2m. The square root of 9, that will be 3 and a 3. And the sign in the middle is a minus. And let me just bring down the 4m here. So this factors to 2m minus 3 times 2m minus 3. So now you guys do your binomial square, 2m minus 3 with a square. Now remember, guys, that if you can factor out a GCF, go ahead and do that. It's going to make your life a lot easier, and that's factoring. You always start with the GCF and then you factor the trinomial, or if you have a different polynomial, you try to factor the polynomial. Alright guys, so the next concept I need to show you is how to solve when you guys can use the square root property in an equation. So in my previous video, section 8.8, we had perfect squared binomials or difference of squares. That's just a different name, difference of squares. And you guys use the square root property to solve. We are going to use the same property, but the equation is going to look a little bit different because we're going to have binomial square to solve. So just a review for the square root property. Remember that if you guys have a number and you want to solve for x, so example here, x squared equals 25, and you guys want to get rid of the squared, well, you guys can take the square root of the x squared, and the square root and the square root cancels. So this one and this one cancels. So you keep the x, but whatever you do to one side, you have to do it to the other side. So you're going to take the square root of the right side. Now, when you take the square root of a number when you're solving, remember that we have two options, one positive number, one negative number. Because when you guys have, in example here, the square root of 25, well, we want to know what number, when you square it, is going to give you a 25. Well, the options are 5. 5 squared is 25. Or negative 5. If you square the negative 5, you guys will get a positive 25. So we need a plus and a minus when you guys find the square root and you're solving. So the square root of 25 will be plus or minus 5. And we do have two options. You guys can separate your answers. We have two answers here. You can write it as negative 5, comma 5. It's very common to write your answer as this as well. So you guys can leave it as x equals plus or minus 5. I'm okay with that in my class. So, but if your teacher wants you to separate your two answers, make sure you guys do that. So let's go ahead and solve by using the square root property, and you have a binomial squared. So I want you guys to see the three examples I have here. All of these are binomial squares, and they are in an equation. You guys have x plus 2 squared equals 36, so binomial squared equals, that's an equation. Binomial squared with an equals, that's an equation. And this one has a fraction, but it is a binomial with a square, and there's an equal sign. So they're all binomial squares, and you want to use the square root property. So the way you guys do this, you are going to cancel the squared first. So we do have the squared outside of the parentheses. and I'm going to take the square root of the left side. That's how you're going to cancel the square. But remember, whatever you do to one side, you are going to do it to the other side. So the square root and the square cancels. You are going to bring down what's inside of the parentheses, and you guys don't need the parentheses anymore because it already canceled with the square. So you guys are going to write x plus 2 equals, and I do need a plus and a minus because we are solving and we're looking for the square root of 36. So we have a plus and a minus 6. Remember, plus and minus for your square root. Now you guys are going to make two equations so you can have your two answers. Remember, in a quadratic equation, and that's going back to the squared, that's a quadratic degree of 2, you need two answers. So in order to find your two answers, you're going to make your two equations, and I'm going to have one with the negative 6. You're just going to separate the signs here. One with the negative 6, so you're going to make an equation, x plus 2 equals negative 6. Let me write that down so you can see it. X plus 2 equals negative 6, comma, and the other equation will be x plus 2 equals positive 6. You guys solve each equation. You guys subtract 2 here, cancels, x equals negative 8. On the other one, you subtract 2 to cancel this one, so x equals positive 4. So my two answers will be a negative 8 and a 4. I'm not using plus or minus because they're different signs, they're different numbers, negative 8 and positive 4. And we have two answers for this quadratic equation. So that's the idea. When you guys have a binomial squared, just get rid of the square by using the square root property. So this one here, same idea. You guys are going to cancel the square. So I'm going to take the square root here and the square root over here. So the square root and the square cancels. I'm going to bring down the x plus the 5 equals. I need a plus and a minus. Now guys, there's an issue here, because if you try to find the square root of 7, well, 7 is not a perfect square number. Can you guys use a calculator? Yes, you can, but I don't want to see decimals for my answer. I want to keep the exact answer, which means do not use a calculator to find what is the square root of 7. You guys can do that in the calculator, but the calculator will give you guys a decimal, and that decimal can be an irrational number, which means it keeps going and going and going to infinity. But you guys will have to round to write your answer. So I don't want to round. I want to have the exact answer. So I'm going to keep it as a radical form. Radical means you just keep the square root and the 7. Don't change that to a decimal. Now the next step, same thing as the one before. You guys will make two equations. X plus 5 equals negative square root of 7. That's one equation. And x plus 5 equals positive square root of 7. So you separate the two equations. You have one negative, one positive, and then you guys solve. So you're going to subtract 5 here and subtract 5 over here. We know that's going to cancel. So we have x equals, now let me tell you guys what to do here. Notice the square root of 7, we don't know what that is, and 5 is an integer, it's not a square root. So those guys, you guys cannot subtract. First of all, they're not like terms. One has a square root, the other one doesn't have a square root. And since we don't know what is the square root of 7 with that calculator, well, we don't know what to subtract to the 5. So all you have to do, guys, you're going to write down your two numbers side by side with the integer first, negative 5, minus the square root of 7. And that's a radical form answer. Our answer has a square root, and that's fine. We know the answer is negative 5 minus the square root of 7. If you guys want to know what's the decimal, you can go to the calculator, you can use one, you can put negative 5 minus the square root of 7, and you guys will get a decimal. But I'm not looking for decimals. Once again, guys, you keep it as an exact answer with a radical. Over here, you subtract 5 from both sides. So I'm going to have x equals, this cancels, negative 5 plus the square root of 7. Why plus? Well, the square root here is positive. Now, there's one more step you guys can do. Since we do not have decimals, and we just have the exact answer as a radical form, well, notice, the two are very alike. There's just one thing different, the minus and the plus. So you guys can rewrite your answer as negative 5 plus or minus, notice I'm using the two signs at the same time, the square root of 7. So this is a very common answer we can use in order to write our exact answer in radical form. You guys have the negative 5 plus or minus the square root of 7. So those are my answers. We have 2 because we do have 2 answers, plus and minus, but we have radical form. And the last one I'm going to show you guys here is you guys have a parenthesis with the square, and you guys want to equal to 0. Well, let's get rid of the square. So I'm going to take the square root of this side here, and I'm going to take the square root of the other side. So the square root and the square cancels. So I'm going to have a 1 over 4x minus 3 equals plus or minus. I need a positive and negative because I'm taking the square root, but we do have the square root of 0. And the square root of 0 is 0. Now think about this, guys. 0 is not negative or positive. It's a neutral number. So what that means is we don't need these two signs because we have a 0 on the right side. So I'm going to get rid of that plus and the minus because, once again, 0 is neutral. So you just put 0 on the right side. You don't need a plus and a minus. Now you guys are going to solve. I'm going to add 3 to both sides. That cancels. 1 over 4x equals 3. And I'm going to get rid of the fraction. So I'm going to multiply by the denominator. So I'm going to multiply by 4. That's my denominator here. So I'm going to get, I multiply 1 times 4. So that's going to be 4. And you keep the denominator, x equals. And then over here, you multiply 3 times 4. And that's going to be 12. This turns into 1, 4 divided by 4. So x equals 12. So that's my answer because you guys got x by itself. Alright guys, I am going to show you guys a couple more because I noticed these equations, they do have perfect square trinomials, and there's 2 ways to solve, but I'm going to show you guys the easiest way to solve a perfect square trinomial. When you guys have a trinomial, meaning that you guys have a p squared or maybe an x squared or an m squared, whatever variable you guys have is squared, and you guys also have the regular p or x with an x1 and a 1 or the m. So we have a p squared and a p. To solve, you must get everything equal to 0. So here, I do have a negative 25 on the right side. So I'm going to add 25 here, and I'm going to add 25 over here. So I'm going to have a 4p squared minus 20p plus 25 equal to 0. Notice the trinomial here. 4 is a perfect square number, 25 is a perfect square number, and it has a plus here. So I'm going to factor in order to solve. So I'm going to have my 2 parentheses here equal to 0. I'm going to take the square root of 4p, and that's going to be 2p and a 2p here. I'm going to take the square root of 25, and that's going to be a 5 and a 5. And my middle sign, it's a minus. So guys, here, since you guys have those binomials equal to 0, and I know that 2 binomials are equal, you don't have to do a binomial square. What you can do is set those 2 parentheses equal to 0, and then you solve a regular equation. So you guys will take the 2p minus 5 equal to 0, and the 2p minus 5 equal to 0, which is the second binomial. Now you guys solve. Plus 5, you add 5 to both sides. So we have a 2p equals 5, divide by 2. And our answer, p equals 5 over 2. Now, common sense, guys, this equation here is the same exact equation as this one. So I don't have to do the work again because this is going to be the same answer as this one, p equals 5 over 2. So we got the answer. Now, I'm showing you guys to solve by using the factors and equal those to 0. In other words, it is the 0 product property. So the next one here, same idea. You guys have a trinomial, but I noticed that you guys can factor out a 2. So I'm going to have a parenthesis equal to 0. I'm going to put the 2 outside, and inside I'm going to have a 4x squared plus 4x plus 1. The trinomial, 4x squared, that's a perfect square number. 1 is a perfect square number. So you guys can factor. I'm going to have my 2 parentheses right here equal to 0. Let me put the 2 outside. And then I'm going to take the square root of 4x squared. That'll be 2x. and the 2x here. The square root of 1 be 1 and 1 here. And the middle term is plus, so you put a plus here and a plus over here. Now you guys are going to equal everything to 0. So I'm going to take the 2 outside of the parentheses, equal that to 0. 2x plus 1 equal to 0. And 2x plus 1 equal to 0. Now this one here, 2 equals 0 is false, so you guys ignore that. It doesn't even have a variable, so you guys cannot solve. But over here, subtract 1 from both sides. So we get a 2x equals negative 1. You divide by 2. So this turns into 1. X equals negative 1/2. And the second equation, this one here, is the same one as this one. So you guys don't have to do the work again. I know that's going to be the same answer as x equals negative 1. So this kind of problem, you guys have a perfect square trinomial where you guys can factor and solve. If you guys have a binomial, the parentheses, binomial with the squared, then you guys can use the square root property in order to solve. Alright guys, so this concludes the video for this section. If you guys like my videos, you guys can click the like button. You can also subscribe to my channel and make sure you guys practice, and I'll see you guys later.